Hello dear, welcome to my channel. In this video, I will show you the complete step to perform the computation fluid dynamic analysis. First of all, I open the ANSYS Workbench to 2023 R1 version, which is the latest version, and go to the geometry section to sketch to make a 3D model of an automobile. In this project, I will show you how to calculate the drag forces acting on a car. So select a plane, let's say XY. You may choose YZ or ZX plane as well. I choose the XY plane and then select the polyline option to draw the to draw a sketch of an automobile. And this is not mandatory. You can draw the sketch as per your own requirement. It is also an option that you can make a model on any other software, CAD software, then import that model to ANSYS and perform the analysis. The next step is the dimension step. You go to the dimension tab, click the general option and draw the dimensions of a car. Then you can edit dimensions just as I am showing to you. I change the H1 dimension 3.5 feet, H3 to 8 feet. You can select or change any dimension as you require. After that, go to the draw section, choose the circle option and draw the circles which represents core of tiles of core. Then modify the dimensions as I change the dimensions to 1.5 feet diameter of a tiles. Then go to the trim option and trim the lines. This is very vital step because you have to trim the intersection lines of two sketches in order to perform the extrude option. Extrude option convert your 2D geometry into 3D. Perform that extrude option same as I am showing. Oh, look, there is a problem. All the ties are extruded. Let's see what's the problem. Oh, I remember. I forgot to subtract the intersection parts of these two sketches. That is the inner radius of the circle. You have to trim that as well to perform the extrude step. Yes, our extrusion is completed and 3D model of a car is generated. The next step is the enclosure generation. In fact, enclosure is our area of concern because to calculate the fluid forces such as the drag forces, viscous forces, you must perform analysis on an enclosure rather than a core. I create an enclosure 3 feet to greater than 3 feet to each axis of a core. Then subtract this vehicle to the enclosure to create a fluid domain. When you have to calculate the if you have to calculate the static structural forces, moment of inertia, deformations, then area of concern is the automobile. But if you have to calculate the fluid forces, then area of concern is the enclosure. You can subtract this by using a Boolean operation as I am doing right now. And generate a 1.1 body, rename it to the fluid name. And that's it. Your CAD model or fluid domain is generated and you are set to calculate the next step is to create a mesh. Go to the mesh option, right click on the option and choose the edit. First of all, name the boundaries of your domain. Front wall of a car known as the velocity inlet, and a back wall of the car you can rename it to the pressure outlet, because the flow, air is flowing from the front to the back end. And then choose the car wall and name it to the automobile or vehicle. Which one is easier to do? I name it to the automobile. Then go to the mesh, and I will generate a automatic mesh because our geometry is simple. Go to the quality and then choose a smoothing to the high, smoothing option, high, and then generate a mesh. In next videos, I will show you how to generate a mm, quality mesh and use the other options such as inflation, or how to generate the hexahedral meshes, or how to slice a body. But from so on, this mesh will serve our purpose. You can also check the statistic, that is that is the how much number of elements are, and the quality of a mesh as well. Then right click and update the mesh. Now we will proceed to the third step, which is the setup, known as setup. Click the start option, so that console of setup will open. In this step you have to choose the models and define the equations. First of all, change the units that is appropriate to you. I will change the velocity units from meter per second to the kilometer per hour, because this unit is easy to interpret. And then enable the gravity and apply it to the negative y direction. Enter the standard value of gravitational acceleration, is 9.8 meter per second square. Then go to the model and select the viscous SSTK omega model, because in this scenario our fluid will be turbulent. All other parameters must be proceed as default values. Then go to the fluid and select the air, having the default properties thermal and physical. Then go to the cell zone conditions and check whether the type is fluid or solid. It must be fluid. Then go to the body conditions and apply the velocity 100 km per hour as inlet conditions, and by default ANSYS will take a pressure outlet at atmospheric pressure. As I'm also interested in calculation of the coefficient of drag, so go to the for that I must know the frontal area. In ANSYS there is an option known as projected area, from which you can calculate the area. I said the automobile and calculate the frontal area, and then enter it to the reference values. That will be helpful in calculation of the coefficient of drag. In this console you can also change the velocity to 3.59 to 100 km per hour. Then go to the report and select the parameter known as the drag force, and rename it so that you can also see the drag forces during simulations. You can rename it as suitable to you. Then go to the method and select a coupled scheme with the pressure velocity coupling, and then go to the initialization and select the hybrid initialize. Go to the run calculations tab and enter the number of iterations and click on the run case. You may change the number of iteration as per requirement. As per experience, I know that in 100 iterations our solution will be converged. If it's not, then I will go for another 100 or 200 iterations. You can see the drag forces are pretty much constant after 50 iterations, so our result is converged. It can also be confirmed by other residual parameters by checking other residual parameters. Okay, this calculation is completed, and now we can easily. The last step is the post processing step. In this step, you can edit the option and go to the force, and it is -1 because drag force is always acting to the negative direction of the automatic movement. And you can see the drag force is 1095 Newton, which is acting on a car. So in this way, you can calculate a drag force. In post processing, you may draw the contours, streamlines, and make animations. Now, first of all, I am drawing a velocity contour on a car to know the um, air particle velocities after hitting the car. You can see the velocity is about between 0 and 4.5 meter per second. Then I am drawing a streamline to know the position or the air particle path of travel. You can see how the air layers are moving against a car. Then select a streamline and make an animation. These are just a tool to present your result, and ask me in comments. I hope you will share this video and come to this channel again for another exciting projects. Thank you very much.